we're going to jump into our first of many transformations lessons. Now, when I'm talking about transformations, I'm talking about taking this quadratic parent function that you see here, that super boring version of a parabola, and changing it in some way. We're going to change the size and location of this parabola. That is a transformation. Taking that boring dashed parent function that's going to be graphed on all of these, you'll see that dashed parent function is there, and we're going to do something to the equation to move the graph or to change the location and size of the graph. Okay, we're only going to go over 3 of them today. The 2 that are underneath the heading called translations. Translations is a fancy way to talk about like sliding it side to side. And you've actually talked about these types of transformations before with shapes on a coordinate grid. And we're going to do the same thing. This time our shape just happens to be a function, happens to be a quadratic. So when we're talking about moving something vertically, vertical movements are either going to go up or they're going to go down. Now, the way that we know we are moving a function up or down, if you notice here, we are adding or subtracting some number at the end of the function on the outside of the parentheses. If I'm adding a number back there, like say plus 3, it's going to move up because positive is up. If I add a negative number or I see just subtraction down at the end, I'm going to be going down because it's downwards. And that's what's going to happen to these parabolas if we add or subtract numbers at the end of the equation. We're going to change the up or down for that vertex and for all of the points involved. Now we can also horizontally slide or translate these parabolas to the right or to the left. Remember, horizontal is side to side. However, do you notice that this time, instead of being outside and behind it, we're actually adding or subtracting that letter H inside that set of parentheses. I kind of covered it up with my drawing here. Let me try that again. I'll just underline it. You see how it's inside the parentheses. If you see that there is minus H inside that parentheses, as if you're subtracting a number away, it's the opposite direction than you think. It's actually going to go to the right, even though that direction is positive. And if you see a positive number inside the parentheses, it's actually going to go to the left, which is, again, kind of backwards because it's going towards the negative numbers, even though it's positive. Now that is because all horizontal transformations are inside a set of parentheses and go the opposite direction. So you're gonna hear me saying HIO a lot. Horizontal is inside and opposite. If you're a student who's inside my classroom, I do have a poster of this hanging up, and you've probably always wondered what HIO meant. Horizontal transformations go inside the set of parentheses and go the opposite direction than you think. Now, the last transformation we're going to talk about today is our reflections. There are 2 types of reflections, but they're really pretty simple. They can either be over the x-axis or over the y-axis. So for over the x-axis, let me highlight the x-axis for us. I'm just going to bold it. So here's the x-axis. And when I say I want to reflect it, that means that I'm taking all of the points in the parent parabola and I'm tossing them or reflecting them or flipping them over the axis. I know that this happens when I see a negative sign in the very front of the function. It creates a reflected parabola. Sometimes we call this the sad parabola. Wow, I spelled parabola wrong. You have your happy parabola and your sad parabola. Then if we look at reflecting over the y-axis, this is the y-axis. So again, I want to flip all of the coordinate points for that function over the y-axis. I want to reflect them or flip them. Do y'all notice it really doesn't look different than the parent function? And that's okay. There's no visual change for a reflection over the y-axis for our parabolas that we'll deal with in this class. There are other functions They're called odd functions. This is an even function that will look different when you reflect it over the y-axis. It's just not a parabola because it's symmetrical. Cool, let's take a look at each and every one of these independently of one another on the inside. We're going to be translating or transforming the parent function in 6 different ways. If you look at this, it says it's a vertical translation up. That's how it's going to tell you. It's going to be a vertical translation up a certain number of units. Now, how many units am I going to move this parabola up? Yeah, you see how there's a +1 at the end of these equations? These are the same thing. That's my plus k. That means that k is going to be equal to 1, and I'm moving every single coordinate point up 1 unit, up 1 unit, up 1 unit. So all of them get shifted or slid or translated up 1 unit, and then I can play connect the dots and make my new parabola. What happens if I'm asking you to vertically translate something down? How do I know that this means to go down? Yeah, since I'm subtracting something at the end, that means that my k value is actually negative. And that means I'm going down 4 units. So each and every one of these points, 1, 2, 3, 4, I'm going to move down 4 units. All of them get moved down 4 units. And then, again, I can sketch my parabola using those new translated points, and I have graphed my parabola. So vertical is up and down, up is positive, down is negative. Makes a lot of sense. Then we get to the horizontal transformations. Now, hopefully you remember that I said something funky about horizontal, that the horizontal transformations are inside and the opposite direction than you think. So since this first one is asking me to translate it to the right, right directions is normally positive numbers. But you're going to see a negative number inside that parentheses. So even though it's negative, it's inside, so it's the opposite. We go towards +3. I'm going to shift every single point over 3 units. And that's going to be my transformed parabola towards the right 3 units because h is equal to 3, the opposite. Horizontally translating things to the left. Left is normally negative, but since it's horizontal, it's going to be inside and the opposite. So inside here you see +4. We know that h is the opposite. This h would be -4, which means I'm moving things towards -4 to the left. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 2, 3, a little off the graph, that's fine. 1, 2, 3, 4. And there I have my, crooked parabola, it's fine. My parabola, that's a little bit wobbly. It has moved to the left 4 units because it's inside and opposite. Now let's work on our reflections. On our reflection, we have first a reflection over the x-axis. Now remember, the x-axis is the flat axis here, so where I'm actually reflecting every single one of those coordinate points over that axis. I know that this happens because we have a negative sign outside of the parentheses or in front of the entire function itself. That's my indicator that it's going to be a sad parabola. So all of these get flipped over the axis and I create my sad parabola. Well, sad parabola. A nice reflection over the x-axis, also known as the flip or the sad parabola. Remembering we have this last reflection that you won't see that often because it, doesn't really change the function for us. When you get an odd function, you'll see it. But we know that this is happening inside. Okay? If it's happening inside, that means it's flipping or reflecting over this vertical axis. But it just happens to be that if I flip all of these points over, they actually flip right back on to the opposite point. So it doesn't look any different from the parent function, but I have reflected it over the y-axis. Remember, there's no visual change for quadratics when I'm doing a reflection over the y-axis, because they just reflect right on top of each other. Those are our new vocabulary words for today. There's lots of vocabulary associated with transformations, but a lot of it makes sense. Vertical translation, either up or down, because vertical is up and down. Horizontal translation, or sliding left and right, because it goes to the left and right. And then reflection, or flipping over each of the axes. We're going to spend a lot of time doing multiple transformations to a function at the same time. It's going to be really fun in class. This is a very visual concept, so be ready to draw and be ready to graph. See y'all in class.